Alright, what's up everybody? We are into 6.5 for rhombi and squares. Okay, so we've talked about parallelograms, we've talked about rectangles. Rhombus are going to have their own specific rules. Then a square combines everything. So it combines everything from a parallelogram, a rectangle, and a rhombus. So we're going to first start off by hitting the rhombus. Okay, so opposite sides are parallel congruent. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. Okay, but now the add-ons, okay, are going to be that all four sides are congruent. Okay, so notice for right here I already have opposite sides being parallel, but now all four sides are the same length. So I have a single dash for all four sides. Next is the diagonals are perpendicular. So remember, in a rectangle, the diagonals are congruent. In a rhombus, they're not congruent, but now they are perpendicular. So what happens is you get four right triangles inside this rhombus, and all four triangles are the same length. Okay? So we also know that they are being bisected, so AC splits into two congruent, and DB splits into two congruent. Okay? And then the next one is the diagonals are also angle bisectors as well. So this is the first time we've had the bisection of angles. Okay, so that means that angle A and angle C both get cut in half. Remember, because those are also still congruent. A is congruent to C, but when you draw that diagonal in, it's cutting both those angles in half. The same thing is true with D and B. D is congruent to B, but when you draw that diagonal in, it cuts both angles in half. Okay? Whoops. And so again, just remember that these diagonals are also cutting each other in half, or being bisected. So those are the three new things for a rhombus. All four sides are congruent, the diagonals are perpendicular, and the diagonals are angle bisectors. And it's also important to note that all four of those triangles, 1, 2, 3, 4, are all exactly the same size, so they're all congruent. Okay. So let's go ahead and look at this diagram. Go ahead and pause this if you need to. Copy this down. I wasn't able to make the outline for this today. So it says WXYZ is a rhombus. They're telling us that WX is 4. Just go ahead and label that as being 4. And they're also telling us that WXY, so this entire angle right here, is 60 degrees. And so based off that information, we should be able to fill out everything else. Okay? So let's see what we can do. So XY, we know that XY is going to be congruent to WX, so XY is 4. Okay. Angle 2. Now, before we get to angle 2, let's look at angle 3 and 4. So I know that this entire angle right here is 60 degrees. Now remember, that diagonal right here is bisecting that angle. So that means that angle 3 and 4 are both 60. Excuse me, not 60, 30. All right. The next thing to remember is that these two diagonals are perpendicular. So that means that this is a right angle. So now if I'm looking at our right angle in angle 3 and angle 2, I have this little right triangle right here. And so if I know that this yellow angle is 30, and I know this angle is 90, I know that all three angles have to add to 180. That means that angle 2 has to be 60 degrees, which means also angle 1 has to be 60 degrees. Okay? Now, we don't have the knowledge yet to find WO or OX. Okay, that would be that trig information that I talked about previously when we were looking at the rectangle in the parallelogram homework. So don't worry about WO or OX or WY, because that would be something we would need trig for, okay? But for ZWX, angle ZWX, Z to W to X, this angle right here, well, remember we found that angle 2 is 60, so if angle 2 is 60, that means angle 1 has to be 60, which means the whole thing has to be 120 degrees. Okay? So again, guys, I would have had to have given you, like, to solve for WO and OX, I would have maybe had to give you that this entire length in purple was like, I don't know, like 10 or something like that. If I knew that that was 10, okay, so let's say, for example, that ZX equals 10, well, then I know that each of these would be 5, and then once I know that that's 5, then I would use Pythagorean theorem to find these two sides right here, okay? But again, since I didn't give it to you, we can't find that information yet. Let's look at numbers 9 and 10 here real quick. So just finding missing angle measurements. So both of these are rhombi. So if these are rhombus, I know that this is 25. I know that this angle would also be 25 and 25. Because remember, this is an angle bisector, and I also know that these two angles are congruent, so we're good there. I know that this is a right angle here, so that would be 90. And to find 3 and 2, this angle's 50. Well, the green angle and the orange angle are consecutive, which means they have to be supplementary. So orange plus green would have to be 180. Well, if green's 50, that means that orange would have to be 130 degrees, the whole thing. So that means that angle 3 and angle 2 would have to be each be 65 degrees. 130 divided by 2. Okay. Same kind of concept for number 10, right? We've got our right angle. I know that's going to be 90, and then I know this would be 68, 68, 68. And then to find angle 1, I could do 180 minus 68 twice, okay? Or I could do 180 minus 68 minus 90, since I'm going to focus on this right triangle right here, and that would give me 22 degrees. Okay. So big thing for a rhombus, all four sides are the same length, the diagonals are perpendicular, and the diagonals are angle bisectors. So now when we move to a square, everything's true. So there's nothing new for me to tell you. It's just that every single thing we've learned about parallelograms, rectangles, and rhombus, all of those apply to a square. Okay, so if I look at this diagram now, I know that EF is 10. So I know that this length is 10. Well, that means that all four sides are 10. So that means FG is 10. That means that, do I have any other ones? EI, IF, okay. Now, if I want to find any of these lengths, so here and here, I need to find this diagonal length. Remember, this is a right angle, so I can use Pythagorean theorem. 10 squared plus 10 squared equals, we'll just call that x squared. So 100 plus 100 equals x squared. 200 equals x squared. The square root of 200 is 14.2. So one diagonal length of our square is 14.2. So that means that HF is 14.2 and EG is also 14.2. Then if I wanted to find the length of half of one of those, like EI and IF, that would be just half of those lengths. Okay? And the last thing is just understanding the angles. Remember, so we have diagonals of a rhombus are perpendicular, so that means diagonals of a square are also perpendicular. So angle 1 is 90 degrees. And then remember, since it's a rectangle, these corners are right angles as well. So that means EFG is also 90 degrees. EIF also 90 degrees. Sorry, I thought the I was a 90. Then angle 1 is down here in the corner. So remember, the diagonals are also angle bisectors, so that means that angle 1, angle 3, angle 2, and angle 4 are all 45 degrees. Okay. So guys, homework for today reviews rectangles, rhombus, and squares. And hopefully try to keep all of your properties separate between rectangle and rhombus. But remember, they all come back together for the square.